My name is Jeff Maynard, and I'm a Principal Product Manager for AWS IoT Analytics and Applications. This is my colleague, John Morkel. He's a Software Development Manager for the same group. And welcome to IoT219, Customer Showcase for IoT Analytics. Today, we're going to give you a quick walkthrough of the IoT Analytics service. We're going to provide you a demo, going all the way from data ingest all the way to executing a machine learning container. And then we're going to talk a little bit about what customers are using IoT Analytics to do today. And then we're going to talk about a couple use cases a little bit more specifically, one of which is what Verizon and the city of San Jose are doing, and how IoT Analytics is helping them, as well as LOC Soft and Vantage Power. So what is IoT Analytics? Build this out. Excellent. It's a service that helps you process, enrich, store, analyze, and visualize IoT data for manufacturers and enterprises. We ended up talking to a bunch of customers, and customers told us that the biggest challenges that they had was IoT data is noisy, it contains a lot of gaps and false readings, and what they really wanted to be able to do is figure out a way to help filter, process, and enrich that data, store it, both in its raw form and in a processed form, and be able to easily query that data and create data sets so they can run advanced analytics on top of, or visualize. So what's the workflow look like for IoT Analytics? Today, IoT Analytics is able to ingest data natively from IoT Core through the IoT Core rules engine. We can also ingest data from any other source, like S3 or Kinesis, through our put message API. That data makes its way into a channel. Channel is the entry point into the IoT Analytics. That data will then be sent to a pipeline that you can author. And in the pipeline, you'll be able to transform, enrich, and filter the messages that you're sending to the service. The process data will make its way to a process data store. And on top of this, you can query to create these data sets. These data sets can be specific by asset, a region, a time period, whatever you're looking for. These data sets can then be used to go into visualization tools, or you can do advanced analysis on top of them. I really hate this animation. Cool. So the first component is a channel. It's the entry point into IoT Analytics. We're able to, like I said, pull data in from a variety of different sources. We're data format agnostic, so we can ingest binary or JSON. But it's important to note that if you're going to give us a binary payload, you're going to have to decode it inside the pipeline because we're not going to know how you encoded it. And then with it, as well as any other AWS service, we're elastically scalable in our ingestion. The data that comes in from a channel is then sent to a pipeline. And you can have a channel feed a number of different pipelines. So there's an end-to-end relationship here. And in these pipelines, you can do filtering, so you can purge outliers, remove any irrelevant data that you have. You can do some transformation. So typically, we have customers that are taking amperage readings and converting it to a variable, or they're converting Celsius to Fahrenheit, things like that. You can then enrich. So we have the ability to pull in data from the MQTT topic header, device registry, and device shadow, and embed that inside the JSON payload. And then we also provide you the ability to do custom preprocessing. So Lambda, the Swiss Army knife, allows you to reach out into any other service. You can pull in information from an external weather source, your ERP system, whatever you need, and embed that inside the JSON payload as well. Two important things to note when it comes to pipelines. The first is that we batch messages every 30 seconds. We do this prior to enrichment for two reasons. It allows us to make sure that your pipelines will scale effectively, but also we don't want to consume all of your Lambda fleet. And so we're looking to help you be a little bit more cost efficient when it comes to deploying Lambda. And then we also make it really easy for you to replicate your pipelines. At the channel level, we store a raw immutable data store for you of all the messages that have come through that channel. And then what you can do is you can replicate a pipeline. You can change it. Maybe you want to do a little bit of A/B testing. And then you can replay the data from a channel through that new pipeline and test and see if it's doing exactly what you expect. We have two different types of data stores. I touched on one, which is this authoritative store of raw data that lives at the channel. This is immutable because customers asked they needed the ability to have auditability for all the messages that are coming in. And they also wanted to be able to replay that data through multiple different pipelines to test hypotheses, allow their data scientists to be a little bit more agile. We also have a process data store, and this is optimized for time series and IoT workloads. So it's partitioned by time, and it's more than a single database. So we've actually created an abstraction layer. And what this allows us to do is as we build out new technologies, we can just slide them underneath, and you get different types of data stores in the future. And then across all of our data stores, we give you manageable data retention policies. So if you want to store your data for a day, 2 days, 60 days, whatever your requirement is, you can author those retention policies individually at the process data store and the raw data store. Data sets are kind of the workhorse of the service. They are the result of running SQL queries on top of the data store, process data store. These queries can be run ad hoc or scheduled. They result in a popular tabular format. You can then pull these data sets into QuickSight so that you can actually inspect and take a look at those data sets. You can also have access to them via an API, console download, or you can pull them into Jupyter notebooks or containers. And then because the service is built so that data scientists and data engineers can use it, we built a console query editor that will allow you to then write your SQL queries, run them, and have access to the resulting data set. As I mentioned, you're able to take those data sets and push them into Jupyter notebooks through our integration with SageMaker. So this allows you to build your machine learning models, and then you can actually containerize those Jupyter notebooks and deploy them back into the service. So you can build and train your models. To help you get started, we've provided a couple ML notebook templates for predictive maintenance, anomaly detection, fleet segmentation, and forecasting. These are for if you don't have a lot of experience with machine learning. So they're pretty basic, but they're great starting points to get you up and running. And then anything that you've built in SageMaker, you can pull in data sets from IoT Analytics and run those notebooks on top of the data sets. Also, if you have your own containers, you've built out your own custom analysis. If you can bring that Docker container into the container registry, we can then deploy that container inside the service to run on our data sets. And then you can even visualize the container, the Jupyter Notebook containers, the outputs in the console. So again, we're trying to build this with data engineers and data scientists in mind. Customers wanted to make sure that they didn't have to scan the history of all their data every single time they wanted to recreate a data set. So we provide them the ability to do incremental data sets. So you can scan incremental amounts of the data store, and then the resulting data set, you can then do any kind of analytics that you need to do. This allows you to increase your performance, and it helps reduce costs. One of the fun features of the service and useful ones is you can actually schedule your queries and containers. So what this means is you can, as data is coming in to the service, you can schedule the query to run, and the resulting data set can then be pulled into a container that you've already deployed into the service, and it will execute that container and then do whatever you want to do, whatever you want the container to actually do. So it allows you to automate these analytical workflows. So if you've built your machine learning model inside of SageMaker, you've trained it on top of IoT Analytics data sets, you're then able to essentially operationalize these containers so that you have an end-to-end workflow. So in a quick summary, we went over channels and that they're the entry point. We can ingest data in binary and JSON, and that they have channels have a raw data store attached to them. We went over pipelines where you can filter, transform, and enrich that data. Data stores, so the process data store, where you can do these time series optimized SQL queries. And then the data sets, obviously the workhorse, the result set of querying on top of the data store. And then our integration with SageMaker and Jupyter Notebooks. I'd like to hand it over to John to go through a demo of IoT Analytics.
Thanks, Jeff. You'll hear me? All right, so I'm going to give you just a little bit of context for my demo before I actually jump into it. So the application that I'm going to be showing you today of IoT Analytics is about an astronomical observatory. So astronomical observatory is obviously using a telescope looking up at the sky during the night to take photographs of the sky. And obviously, you can't really do a whole lot of that if the weather is bad, if the sky is cloudy, or during the day. So you generally would want to be running these observation sessions during the nice, clear nights. And some of these observation installations are in remote locations, and it's actually quite useful to have the ability to remotely trigger these things and the stations themselves to be self-sufficient in terms of knowing when they can and can't run an observation. So the data that I'm going to be using here is from a real observatory. Basically, we have three primary inputs that we're ingesting into IoT Analytics. The first two are related to the temperature of the ground, or the ambient temperature, and then the temperature of the sky. And this is just using an infrared sensor. And the infrared sensor gives you the ability to compare those two to one another, and you actually get a very reliable measure of whether it is overcast or not. So as you might expect, that when it's clear skies, the temperature of the sky is quite a lot lower than the temperature of the ground. So that would indicate clear skies. If it's overcast or low cloud, you would see the temperature differential would be quite a lot less. And then if it's almost in line with one another, that indicates that your weather conditions are either snowy or raining, because then the gradient of temperature from the ground to the sky is almost constant. So the second input that we have here to this particular analysis tool that we're using here with Jupyter Notebooks is the light. There's a light sensor, which basically a photoresistor, which picks up the ambient light and turns that into a signal which gives you the amount of lumens that the sort of sky is currently lit up with, and that gives you a pretty easy way to tell whether it's night or day. And combine those two together, and I'll walk you through now the actual analysis we do of that input data to be able to determine for any particular period of time the weather conditions and whether it's day or night, or at least whether it's dark outside. So let me just quickly get myself set up here. Okay. All right, so just if you all haven't seen this is the IoT Analytics console. And I'm going to just give you a little bit of a walkthrough of the setup that I have here so that you can kind of get a feel for the different parts. So if I go look at my, so I have a channel that this data is being ingested into, as Jeff was telling you about. That's where all my raw data lands, and this is telemetry that's coming directly from the sensors, and they're writing this directly via IoT MQTT messages into this IoT Analytics channel. We have a rule that will redirect IoT MQTT topics to IoT Analytics. Then the pipeline here, if I just quickly show you this. Let me know if this is too small. Let me actually just... so you can see it's a pretty boring pipeline. It just has a channel and a data store. There's not a lot of transformation happening in the middle. And that's because the structure of the data is actually well suited to analysis as it comes in from the sensors. So we're posting it in JSON format, and there's no real additional transformations needed in the pipeline at this point. and the Jupyter Notebook takes care of any other transformations we need. So that's the setup of the pipeline, and then we'll move on to the analysis part here. So Jeff also mentioned earlier about data sets. So this is really where the analysis begins. We have two data sets that you can see here. The one you'll notice is a query type data set, and the other is a container. And the container type is the newer feature of IoT Analytics that was launched just a few months back, which essentially gives you the ability to generate data sets based on the output of your Jupyter Notebooks. And I'll get into the details of that very shortly. So over here, you'll see I have a notebook instance, and this is a containerized notebook that is running. Let me just quickly flip us over through to that interface. And so here we have the Jupyter Notebook interface, and you can see the Python code as I've written it here for the demo. And each of these cells here is basically a step of the analysis that we'll go through. And I'll kind of guide you through that very quickly. I do want to very quickly point out to you the containerization feature here. Let me just make a quick modification. Okay, and then I'll just rerun my analysis. And okay, so what I'm going to do is so this takes a couple minutes. I'm just going to kick it off now. Oops, no spaces. No colons either, okay. I'm just going to click through this quickly. So there is a feature on the notebooks of variables. I'm not making use of that particular feature for these demos. If you want more details on that, you can check out in our documentation. So I have an Elastic container registry here for the purposes of storing my Jupyter Notebook containers once they've been containerized. And so let me just click the containerize button there. And okay, so let me take you back to our Jupyter Notebook. While the demos, while this container is being created so that we can now use it as an input to our data set. Actually, sorry, let me just quickly flip back to the IoT Analytics console. Okay, so the data sets that you see here have been generated on they can be generated on a regular schedule, or they can be triggered through various events. I'm going to trigger it manually just for the purposes of this demo. So this particular data set is, you can see the SQL query there is a pretty basic one. It's basically just pulling all the data from the data store. The one interesting part about this, though, is we're using the Delta windows that Jeff mentioned earlier, which means that we are not going to reanalyze any data that's already been analyzed. It'll only analyze new data. So because we have a Delta window set up here, that's basically going to limit the amount of time that this needs to run, because it's only going to be incremental. So I'm going to kick this off. Okay, now while that's running, I'll show you here. This is the container data set, and you can see that this has got a trigger set up here, which is actually triggered off of this data set. So every time that data set is run and it gets generated anew, the next thing that immediately happens after that is the container data set will be run with that as the input to it. So you can do your analysis. Your analysis can be triggered every single time you have a new data set available for analysis. And typically these data sets would be based on a time interval. So this probably, okay, so that's still creating. Let me just show you then the various steps. Okay, so we're still containerizing there, making good progress. So I'm not going to bore you too much with the details of this, but essentially what this Jupyter Notebook script is doing is reading in the data from the data set, and it's doing some transformations on the data. So we read in basically the ground temperature, the sky temperature, and the light sensor value. And then we also calculate this delta of the temperatures between ground and sky. And then we plot that data over here. So you can see they're all on the same axis, but the ground and the sky temperature, you can see, are tracking each other pretty closely. And you can see this blue line here is our delta, and it's also sort of very close to 0. So from what I was mentioning earlier, we can kind of deduce that this looks like it's in either a snow or a rain weather condition. And this is taken from, as I said, a real observatory in Seattle. And the lumens here you can see are around the 75% average, and that would indicate to us that we're during the day. So let me actually just scroll down here, and you can see some of the logic about whether we do some basic stats on those measurements that we have, and we then figure out whether it's a clear day, whether there's low cloud, high cloud, just depending on some thresholds that we've established here. And then the analysis actually prints out what the determination is of the weather conditions. So you can see here, rain or snow, and based on the light level, it prints out whether we're in daytime or nighttime. And finally, this is a message that actually gets sent to my phone via SNS. This is in JSON format, but it kind of lets me know what the latest run and the results of the analysis are here. I could format this a little bit more neatly, but I look at JSON all the time, so this makes sense to me. And then lastly, we save our state in S3, and we publish a message on an IoT topic, an MQTT topic, and then this can be used to trigger the observation. So if we can tell that our event has met the various criteria that we have for doing an observation, we can actually go and get that started. So that's really the detail there of this analysis. So let's quickly check in again on our containerization. Okay, so the containerization is done. I can actually now flip back to our datasets page on the IoT Analytics console, and you'll see that a few things have happened. So the run that I did for the dataset earlier has completed, and then we can take a look at our container dataset. You can see this is currently running as well. So the analysis that I just showed you in the Jupyter Notebook is currently processing that data that we just saw, and it will produce a new version of this dataset. And then you can see here, we don't have any content to view just now because the analysis is running, but essentially that, we might actually be able to just look at the previous one. There we go. So let me show you the previous run of this, and really it's just the output that we saw in that Jupyter Notebook pane. This is just the output of that run, and you can see basically the analysis results there. And yeah, that's basically everything that I wanted to show to you today. So just in summary, we've got a kind of end-to-end demo of data being ingested from an astronomical observatory for the weather conditions and the light conditions. We're processing that in a Jupyter Notebook, and this can be done on a regular schedule. And then the analysis of this notebook can variously be triggered either via the notebook itself, or you can actually send MQTT messages to the IoT rules engine, and then that will be able to take actions depending on whatever rules you have in place there. Great, so that's everything I had to show to you today. Back to Jeff.
Thanks, John. Can you set me back? Hopefully we're back. Awesome. Thank you so much. I want to spend a couple minutes talking about what customers are doing with IoT Analytics today, some high-level use cases, just so you have an idea the art of the possible here. So we have some customers in oil and gas and energy, and what they're looking to do is better understand the behavior of that field equipment. It's normally out, it's expensive to kind of maintain and do maintenance on, and so they want to better understand that behavior. And what's important to them also is the appropriate context of that data. And so they look to use IoT Analytics to help provide some of that context, our ability to, in our pipeline to reach out and pull in information from other sources. And then they want to take action against the efficiencies. And so you can imagine the output of one of the notebooks, as John mentioned, could be triggering IoT core rules engine event. Here's some of the use cases. Predictive maintenance on general purpose rotating pumps. When I first heard that, I didn't know what that meant. I do now. Battery cell analysis and conditioning. This actually seems to be a big problem, and we'll learn a little bit more about that later. Smart grid and secondary sensor network analysis. So a lot of energy companies today are starting to deploy new IoT sensors, and they want to be able to marry that data to the existing data that is coming off of their smart grid so that they can make better decisions. And then detecting energy consumption and production anomalies, primarily production anomalies. A lot of these energy companies are very worried about safety, obviously. And so if there's anomalies that are happening in terms of how they're generating power or distributing it to the grid, they want to know about that as quickly as possible. We have a lot of customers also that service consumers directly. And what they're really trying to do, again, is understand the behavior of these consumers and how they interact with their products so they can provide them better, unique experiences. So one of the big ones that we've been working with customers on is taking the telemetry data from consumer devices and doing anomaly detection on that, allowing them to automatically create support tickets so they can be proactive in their customer service. Also, just understanding how consumers interact with things like TVs or smart fridges. Everyone went and made everything smart, but then they don't really know how their consumers are actually using them and what features are the most important. And then really being able to power machine learning across large device fleets. So this is going to enable them to find those rare anomalies that are occurring that could yield to a fault and a bad experience for their customer because they're able to look across such a wide range of devices. In manufacturing, we have customers that are doing macro analysis to identify anomalies and do forecasting and such across all of their manufacturing plants. So able to essentially automate some of their quality control at scale, being able to pull in all the various data that's coming from different sensors, humidity, telemetry coming from machines, and being able to look at how all those are affecting the output or the yield of whatever they're manufacturing. One of the big trends that we're seeing with customers is this multi-site or region analytics. Historically, a lot of this data that's being created by manufacturers is siloed in each location, in each manufacturing plant. And corporate headquarters is trying to figure out what is the yield in each location and why is manufacturing plant A so much better than B. But they just don't have the ability to pull all that data together in an easy-to-use tool. And then, essentially, if you think about IoT Analytics, it is a IoT-optimized and managed data lake service with a bunch of analytical capabilities built in. So it stands to reason that manufacturing companies would look to use it like a data lake. We also have a bunch of smart buildings and cities customers, and they're looking to take these siloed data sets that are sometimes owned by municipalities and cities. Some are owned by folks that service them, such as garbage and water and sewer. And they're trying to figure out how do they gain more insights by combining some of these data sets, and then how do they create new data sets and new data streams that they can then give to their folks that provide services to the city so that they can be more efficient, which is then going to help them reduce the cost to their constituents. Some of this, though, starts at smart buildings. So we have customers that are looking to centralize a lot of their building management data into one spot. because what they want to be able to do is run analysis at room, floor, building, as well as region level. Why is building A consuming so much more energy than building B? Very similar to the manufacturing use case. And then they also want to be able to monitor and forecast power grids, very much like the energy use case that I mentioned, but this is more focused on how folks are consuming from the power grid or contributing back. They may not be a power producer, but they could be, have 100 solar panels on their roof and they're contributing back in, and they want to understand when they should draw from the grid, when they should charge batteries, and when they should push back into the grid. And then we have some customers that are looking to do emergency vehicle preemption, so really making it so that they can optimize routes for emergency vehicles so that you can get services from 911 a lot faster and safer. And on that, I'd like to introduce David Tucker from Verizon and Kip Harkness from the city of San Jose to talk about emergency vehicle preemption.
Good afternoon. I'm going to try that again. Good afternoon. Hey, I'm a community organizer at heart, so I like to interact with actual real people. It's good to see you all. I'm Kip Harkness, and I'm Deputy City Manager for the City of San Jose, which I'm sure many of you actually probably spent some time there, but it is an amazingly, astoundingly diverse place. We're a city of over 1 million people, and we have over 800 tech companies that are in San Jose, everybody from Adobe to Zoom, and one of the most extraordinarily diverse populations in any city in the world. We're about a third Asian, with the largest Vietnamese population outside of Vietnam, a third Latino, and then a third white, African American, and other, with other one of our fastest growing segments. We're also one of the most educated cities in North America and in the world, and also one of the most expensive to buy a home in. You can get a starter home now in San Jose for a steal of a median price of $1.2 million. In terms of the city itself, which I'm a part of, we're about 6,200 employees that are charged with providing a really bewildering array of services to those 1 million people. I like to say that we are an A to Z city, right? We have an airport, we have a zoo, and we have everything in between. And on any given day as a city and as deputy city manager, we're worried about getting those now 14 million passengers through our airport using things like information technology and biometrics to speed you through customs if you're an international traveler, all the way to our about 178 zoo animals, including Will Smith, our red panda, and making sure that the temperature in his habitat at night is correct so that he doesn't overheat. And I'm not making up either of those examples. So in that context, what is smart cities? What is innovation? What is IoT? We actually really have this, what I call innovation imperative. And I think there are two things completely external to the city that are driving this innovation imperative. One is you all, folks like Amazon and other tech companies, and what you've done with the consumer experience, especially over the last 10 years. I was explaining to my son the other day the difference between Amazon One-Click, which he knows extremely well, and the Sears catalog, which he had never seen before. Right? And he's like, well, see, that sort of sounds like a really bad business idea. I'm like, well, yes, but that's what we had. And unfortunately, government services are often more like the Sears catalog than they are like Amazon One-Click. So this consumer revolution is driving the change in government services. The other thing that's changing is we're growing, but our revenues aren't. We expect to add about 400,000 more people to San Jose in the next decade, but we are not going to see a similar increase in our revenues. So we're going to have to be more innovative. We're going to have to be a smart city. We're going to have to understand how to use data to see patterns, those patterns to see insights, and that insights to drive action. I'm going to dig down into one particular case study I think that we can all relate to, at least on the receiving end, which is the provision of emergency medical technology and getting trained emergency medical responders to you as quickly as possible when you call 911 or somebody else calls 911 on your behalf. And by the way, pro tip, that's the first thing you should do in an emergency. You should point to somebody and say, you, call 911. It's a guaranteed fail-safe. But how do we get there? There's an awful lot to that. There's a lot of complexity. One of the things that I want to go into a little bit deeper is how do we actually travel to you, the travel time. If you've spent time in San Jose, you know our traffic is also pretty atrocious. Well, if you're having a hard time getting through it, imagine what it's like driving an ambulance or an emergency vehicle through all of that traffic and getting there safely. It's interesting that for firefighters, which is a very dangerous position to have, about 25% of the accidents and deaths that occur for firefighters are not actually on the scenes or in the fires. It's getting to and from the incident itself. And a lot of the most dangerous parts are getting through the intersections which are red lighted while people like you are on your headphones or on your cell phones and are completely distracted. So what we've done is we've put in place a centralized emergency vehicle preemption system, which you see the map of here on all 960 of our signalized intersections. So that when one of our fire trucks comes into any of the red sections, it automatically triggers a green light for them to go through, a literal green light. So the question is, does it actually work? Does it get us there faster? What happens if there's traffic, and can we take that into account? What should we be doing 2 lights in advance? What about optimized routes? What are the patterns where it's working, where it's not working? Honestly, we don't know. And without partners like AWS and without Verizon, we'd be in the dark on the effectiveness of this technology. So I want to turn over to our partner with Verizon.
Thanks, Kip. So I'm David Tucker. I'm with Verizon Smart Communities. Let me tell you where Verizon comes into play here. Verizon Smart Communities is a group or division within Verizon that has been focusing on pulling the assets, technologies, and capabilities across the Verizon portfolio together to help cities like San Jose solve some of these problems. And as we have, I assume it's that one? No, that one. There we go. As we've engaged with cities across the U.S. and as well as internationally, some of the key themes have come up from the pain points within the cities. And you'll see these just categorized. On the left side, it's really mayoral priorities in terms of the vision for their cities and what they want to accomplish, how they can attract competitiveness or attract business to the city and economic development. In the middle column is really the departments, and departments like the Department of Transportation or the emergency response teams that have are operating in silos and have challenges like upgrading their infrastructure or have limited resources, or how do I solve the traffic problems in my city? And those departments are really set up to solve some of those problems, and they work with technology vendors in a vertical, isolated kind of environment to be able to do that. But on the right side of this, you'll see that a lot of those pain points that the cities have are the decreased revenues, or how do I manage infrastructure over the long term? How do I invest in technology when I'm not a technology company? How do I really manage that for the long haul? And how can I do all of that in the environment that I'm in with regulatory or with the privacy concerns that I have for citizens in an open, transparent environment? So as we double click on the challenge of data analytics and data insights, we'll see some common themes coming out of their pain points in how they manage their data. All of us in the technology industry have some of these pain points as well. How do I create a common repository for data across my business? How do I allow for cross collaboration between departments or data insights? How can I secure that data and provide the right access controls and information? How do I take new innovative data sets coming out of things like these IoT solutions or these vertical solutions and enable those to feed my data insights portfolio and give me new insights that I hadn't thought of? And further, how do I do this as in a hosted type or a managed service type of environment so that I don't have to continually invest in buying the next piece of software to go into a data center that my IT team has to manage? I just can't keep pace with that over time. So as we in Verizon, we had been focused a lot on those vertical solutions. And you can see some of the architecture here is really kind of a common model associated with an IoT type of a model. You have IoT devices out of the side, and on the right side we have applications where we were focused in lighting and traffic verticals and parking and pedestrian safety types of solutions. And connecting the dots between those is, how do we communicate and manage those devices? How do we build a data repository that allows us to then layer business logic elements into that? Storage, obviously, authentication, and authorization. And in comes the challenge of how do I engage with somebody like Kip in a problem that he has around emergency response to allow him to bring in data sets that go beyond what I provide as a solution provider and pull in various siloed data from legacy systems or other components. And then how do I, as a provider of this technology, do this in a hosted, managed fashion that allows me to scale and distribute this, not just for the likes of Kip, but how can I reproduce this for other cities in our region so that they can then begin to cross-pollinate? Or how can I create that so that I can do this across the US in a very scale, manageable way? And that is where, as we look to build this out and solve the solution for Kip and around emergency response, IoT Analytics comes in for us. So it's not just about IoT data, but any data. So Kinesis funneling in data sets. It is about pulling in a multiple VPC type of an architecture because we need to be able to take a common set of IoT management data that we're providing for a large number of cities in a managed service fashion. But I also need to be able to allow for the security models and the data isolation and separation, segregation for Kip and his data and the data analysts on his team to be able to log in with the right security authorizations and to be able to correlate the data sets across their departments. They should feel secure in providing us that data set so that they can actually see it in their own type of environment and get that visualization side. So the pipelines and the channels are critical here with IOTA, because we need to be able to take similar types of models and replicate those and then scale them across multiple cities and across regions. And this the framework here and the managed service capabilities of IOTA will allow us to do that in a very scalable fashion, reproducible, and managed environment. So diving back to the solution set, as we worked with San Jose, we pulled in a number of different data sets. We pulled in the emergency response fleet data. We pulled in the traffic congestion data from a different source. We pulled in some Verizon data from our Connect and from our fleet management data. We pulled in some of their historical response, their land use data, their 911 dispatch data. These are all isolated data sets in a very siloed fashion that would be really challenging for a city to pull together in an effective way. And we were able to pull those together and begin to see trends and hotspots and do land use analysis for the city so that they can begin to see the effects and ultimately determine whether or not the emergency response systems and optimizations, the preemption of traffic, actually had an impact on their response times. And then they can expose that data to citizens and say, look, our money that we're spending is actually helping you out, and here's why. We have proof through data that the solutions that we're putting in place for you citizens is working. So Kip?
And from our mayor, Sam Liccardo, has challenged us to be as innovative as the community that we serve. For us, that's a high bar being in San Jose, and we really are at the beginning of this journey of taking data, of seeing patterns, of understanding insights from that and then driving action. But I can tell you that it is really powerful already. I had a chance to do a test run of the emergency vehicle preemption, which meant I got to ride in a fire truck. And one of the interesting things is that it works, but there's one thing that an emergency vehicle does not preempt. It does not preempt a train. So if you've got a train coming through, you don't override the signals when the train is coming through. But what we've realized now is, well, what about if we knew when the train was coming through? Could we optimize the route around the train? And so by doing this, you start to iterate and start to think completely differently about the delivery of these services in ways that we believe can deliver these vital services at much lower costs using existing infrastructure, existing data sets, and connecting them together with these tools. So a big appreciation to Verizon and AWS for being on the start of this journey with us. Thank you.
Kip, David, thank you. Let's see. Okay, At this moment, I'd like to invite Alex to come on up. He's the CEO of Vantage Power and talk about how he's using IoT analytics to understand battery cell optimization.
That's right. Thank you very much, and pleasure to be in Las Vegas with you guys. So, how do I move this forward? There we go. I'll tell you a little bit about my company first. When I co-founded the company back in 2011, our mission was to develop technologies to radically reduce emissions from heavy-duty vehicles and to connect them and to do some really cool things with that connectivity. And I'll tell you why that is and was so important. So in the UK, the average person is twice as likely to die prematurely from poor air quality as you guys are here in the United States. It's not a statistic I'm particularly proud of. But if you look globally, 3.3 million people per year are dying prematurely due to poor air quality. And that's more than HIV, malaria, and influenza combined. So this is a massive global problem, and we are a small part of that solution. So we developed 3 core technology areas to help address this problem in the heavy-duty vehicle space. And that's broadly battery pack technology, vehicle control system technology, and an IoT data and telemetry package. And the problem that I'm going to talk you through today merges all 3 of those elements together to come up with a really innovative solution. We haven't done this on our own. We're really fortunate to have a fantastic partner in the form of LOC Soft supporting us on this journey. So they're a global consulting partner for end-to-end digital solutions. When we first started looking at putting together a telemetry solution about 4 years ago, we looked at about 9 different companies that could provide us with that skill and expertise that we required, and LOC Soft came out on top. So moving on to the problem, I'll give you a bit of engineering to start us off. Battery packs are basically the fundamental element of any electric vehicle, or hybrid vehicle for that matter as well. And pretty much every single battery pack is made up of thousands of individual little cells. If you take our battery pack, which is in that picture over there, there are 1,760 cells. But if you take a Tesla Model S, for example, you've got over 9,000. Now, the problem is, you can guarantee that as millions and billions of these cells, trillions of these cells, end up out there in the field, any one of them will go wrong. Statistically, many of them will go wrong. And that could end up with a slight annoyance for the customer. Maybe the vehicle doesn't have quite the performance that they were expecting, or it's degraded ever so slightly. It could be a lot worse in the sense that it could stop the vehicle from driving. And then you've got a really unhappy customer and potentially a lot of lost revenue. And of course, worst case scenario, you could have a major safety incident. So we were putting out battery packs in the field. They're going into buses in London. So we thought, how are we going to work this out? How are we going to tell which cell is going to fail? How is it going to fail? And when is it going to fail? And the problem here is that actually this is a highly non-linear problem. These batteries are pretty complex. They've got a lot of thermal characteristics, a lot of chemical characteristics that make it quite difficult to predict what is going to go wrong. So to start off with the solution, we did what any company does these days and just collect large amounts of data. And we collected around 2,500 data points per second from each of our battery packs over the course of a year to build up a data set of over 1 trillion voltage points from the cells out in the field. We streamed that data up into the cloud, and I'll talk you through that architecture in a short while. And essentially, we developed a model that established a pass-fail criteria for every single cell in every single battery. But because batteries evolve differently, so for example, if I manufactured 2 batteries right now, and I put one in a vehicle in Las Vegas and one in New York, within a matter of days, they will totally diverge, and you'll have probably, actually it's difficult to say, but I'd probably say the battery pack in Las Vegas would start degrading faster because of the heat. And you can imagine all the different kind of variables, driver, duty cycle, climate, terrain, all of that affecting how that battery pack evolves over time. So that model needs to recalculate on a daily basis exactly what that battery pack and what that cell is doing. So we trialed and iterated that model using those trillion points of historical data, and we trained that model on 4 known failures that we had experienced out in the field. And we deployed this to in-service vehicles at 0 operational risk. The way the architecture works at the moment is all the binary data is taken up from the vehicle and pushed into AWS IoT Analytics, initially into an S3 database. Those use case channels are extracted, and it's then sent into IoT Analytics. And that is not the most effective way of doing it. Then the next stage that we are moving to shortly is getting rid of the S3 database and the IoT pipeline entirely and streaming straight into the analytics platform. So if I just explain why we're using analytics in this, of course, it's a much simplified solution architecture. And ultimately reduces our cost of ownership in building out this platform and developing this technology, gives us much faster access to data and a greater agility and ability to innovate. But the real crux of the matter is, what is the result? After doing all of this, where did we get to? So this is a quote from our CTO and my co-founder. Essentially, using this data, we've been able to find out which cell is going to fail months earlier than we can today. And the best case scenario for us today is to see the data actually showing a fault on the battery in real time. So that's not particularly good if you've got a vehicle on the other side of the world and it's broken down because of a failure in your battery pack. Knowing about it at the time it happens isn't particularly helpful. So having this more than a month additional warning is like a game changer for us. It totally changes the business, because instead of calling up a customer or them calling us up and saying something's wrong with a vehicle, we can call them up and say, guys, we think there's a pretty high likelihood that in the next month there's going to be something wrong in that vehicle. Would you mind scheduling a few hours of downtime for us to come and investigate it? We'll have some people on site in the next couple of weeks, for example. So that way, we have a much, much more reliable product. So we're not waiting for something to go wrong. We're predicting when it's likely to go wrong and can react well in advance. Because we can schedule our support and maintenance a lot better, we can lower that cost, which ultimately lowers the cost to the customer and ultimately ends up with much, much happier customers, which is, of course, what we're all here to do with our businesses. My last slide, what's next for us? We're going to continue to develop and deploy these innovative technologies across our product portfolio. We've already done another trial on a entirely different type of technology. This is on an air compressor system to try and reduce the failures we see on that. And we'll stay in this heavy-duty electrification space where we feel we can make the biggest difference in reducing emissions around the world, and of course continue to try and decrease the cost and increase our customer satisfaction. Thank you very much, and back over to you, Jeff.
Thanks so much, Alex. So, if you'd like to learn more, here's some links. Take a picture, or you can just Google them. Obviously, IoT Analytics, you can find out a little bit more about it through the AWS website. City of San Jose, take a look at what they're doing as they're along their journey to being a smarter city. Verizon has a great host of solutions around their Internet of Things portfolio. And obviously, Vantage Power has their vision of the future. If you have any questions, feel free to contact us, myself or John. We have a couple extra minutes, so we'll be in the back if you have any questions. And then I was asked, because everyone likes beer, there is a pub crawl for IoT from 6 to 8 at the Aria, the Bardot Brasserie, or the Herringbone. So if you want to go and talk to some folks about our IoT solutions and services and what other customers are doing with it, come find us there. Thank you so much, and have a great rest of your reInvent.